I'm Guy Kramer, President and CEO of Hyperstealth Biotechnology Corporation, and in 2010 I figured out invisibility. Quantum stealth is a patent-pending light-bending material that works by bending the light so that only the background is visible and a target, such as a person, is removed from view when behind this material. Here I'm demonstrating version 1 of the material on a riot shield. This allows the target to remain hidden while moving or stationary. The material also makes aiming at the person's critical points, such as the head and chest, much more difficult. In the initial part of this video, my torso is somewhat visible, but as I hold the material farther out to create a greater standoff distance, the torso is nearly invisible, and with a little more distance it would be completely removed. Newer versions allow the target to get closer to the material. What is broadband invisibility? It's the ability to make a target invisible not only within the visible spectrum, but also the near and medium ultraviolet, near infrared, shortwave infrared, and thermal spectrums. I wanted to find a way to hide a tank from aircraft, drones, or satellites overhead while it was still moving. The simple solution was to place one piece of the material on top of the tank with an appropriate standoff distance to allow room for the light to bend. Notice you cannot see the shadow of the tank's large gun on the ground. There are 11 halogen lights in the room, so there are numerous shadows of the material, but not the tank. If there was only one light source like the sun, the shadow the material creates is minimal. Notice while you're watching this that you can see right through the material to the other side of the desk and through the windows. This demonstrates that we can hide a target in 360 degrees. This would be useful for submarine periscopes and the newer photonic masts, as well as communication antennas, radars, and other sensitive intelligence gathering assets that need to remain hidden. When I point a laser at the material, notice how the laser stretches into a horizontal line. It's fanning out, and while the black tube blocks part of the laser line on the inside of the cylinder, it only has a very minimal impact on the laser line on the outside of the material cylinder. It's as if the laser line is going through the black tube unimpeded. If your concern is only from head-on identification, then the target to be hidden doesn't really need to be inside. It could be placed behind the cylinder.
Using a shiny white helmet on a black background and a shiny black helmet on a light-colored background shows how well this material bends the light around the target. One drawback of version 1 is how blurry it is when there's a detailed background behind it. Version 2 shows the background detail because it works differently than version 1. Notice the white Hummer on the left, but can you see the camouflaged Hummer behind the material? Or the bright red one beside it? If the target's too wide or too close to the material, it only becomes partially invisible. This is version 2 large-scale testing. I've aligned the material so the neutral zone is not in the center of the material. This creates dead spots on the two sides of the material to hide targets. Also notice how my image is moving in the same direction when I'm close to the material, but is moving in the opposite direction when I'm farther away. The point at which this switch happens is the flip point, and at that point, even if you did see an indication of the target, it is so distorted that you would probably not be able to identify what the target was. In the next test, I've shifted the neutral zone to the center of the material. This creates a dead zone in the middle of the material in which to hide a target. This is version 2, and as you can see, it's much better than version 1 at hiding objects behind it, as it provides a detailed background, the target can get much closer to the material before being detectable, and it's removing both the horizontal and vertical components of the target. I could edit these videos to make this much more impressive than it actually is, as there's a drawback to the cylinder or tightly curved approach in that it only hides the target at specific viewing angles and enlarges the target at equidistant or equal distance viewing angles. If you're a fan of science fiction, you've probably heard the term phase shift. This is where an object such as a spacecraft in phase can be seen and out of phase becomes cloaked or invisible to anyone outside the craft. The fictional part of this is that until now, we didn't actually have that ability. The term phase shift is also used in physics and typically refers to small-scale or quantum physics. A phase shift occurs when two identical light waves travel to the same point, but they travel different distances to reach that point. If the light wave started out in phase, they will be out of phase at the destination. If the crest of one wave lines up with the trough of the other, in other words, their waves are completely opposite to each other, then they cancel both waves out. This is known as destructive interference. While the term phase shifting seems appropriate for this effect, scientifically that's not what's occurring here. The laser is demonstrating what's happening to the light rays through the double-sided lens. When the target is out of phase, the laser is splitting into two parts, with each laser refracting at 40 degrees, meaning that what you're seeing is the background image 40 degrees to the left and the background image 40 degrees to the right converging to create a neutral zone, and the target is invisible. When the laser is within the in-phase section, the two lasers now converge onto the target, but magnifying the target size to the viewer. If we know what specific direction the viewer will be at, such as hiding a police officer at the side of the road from oncoming traffic, as the police use their radar or lasers to determine oncoming vehicle speed, as the vehicles get closer past the speed detection area, the angle changes and they see a magnified view of the police officer, allowing for the safety the police require so no vehicle accidentally hits them. Then this could be a reasonable solution to removing the target from view.
Within the patent, I've allowed for the manufacture of this material, so the majority only shows the out-of-phase sections, and the in-phase sections would be so minimal that the target would be unidentifiable. We could manufacture the material entirely in the out-of-phase viewing angle, but this would reduce the overall detail we currently have with version 2. Version 13 basically takes the advantage of this material when we start to offset it, that we start to distort the target in behind. And so now you can see there's something weird happening there, because what I've done is I've actually changed the angle of the two lenses in relation to each other. And yeah, you can see something odd is happening, but try and guess that that's a human being or an animal or another target you're trying to hide, and it becomes nearly impossible. And the reason for this version initially was underwater. All these versions work, but you have to be farther away than you do in air because water bends light. And so that refractive index of water has to be factored into this. And so in certain applications, such as a Navy diver using this, where they're trying to hide them coming up on a beach from overhead view, whether it's a ship or observation tower or drones or whatever, something flying over, trying to identify threats, the diver doesn't want to be seen or targeted. And so having a piece of material that's too far away just wouldn't work for them. So we can get it really close. I'm actually holding that right onto my torso, and it's still distorting it. And so now the observer above cannot identify what it's looking at, and with water, you're unlikely to even notice something is down there unless it's solid, right? Well, this doesn't look solid. And so you have enough of this, and we can manipulate the lenses and the angles and everything to configure something that looks better than this. That's where that idea initially came from. But that idea may be applicable to M1 Abrams tank, where this material in the correct configuration, right? Let me just move my body out of there. Sorry, I'm getting a reflection of the lights here too. This may need to be 12 feet away from the tank in order to have this effect on the tank. And so it depends on the width of the object. So a tank is very long and very wide. And in my initial experiments, we were finding that we can do it. We can make a tank completely invisible. Version 1, we can be closer, make it invisible, but it doesn't give that detailed background that you might be looking for. Version 2 need to be about 12 feet away. If you get closer, about 6 to 9 feet, you get a distortion effect happening with version 2, but you can still see something kind of like a tank. But when you start to change this and angle it, now you can't, you know something's there, but your brain is going, I can't connect the dots. I don't know what it is.